front side, and we haven't really gone through. I don't want to do the back side before I go through some other stuff. This is what I'm calling the front side. First five good? Greater than, equal, neg pause? Yeah. Oh, thumbs up. Which one? So the tangent line here would be sloping down with it. Okay, well that's a huge, no, it's very common. You'll see on the next page it gets even more confusing. Alright, this would be 0 greater than those okay? 0 greater. Any discussion, debate, did I get one wrong? What do you got? Yeah. So f prime of I is there. F prime of j is there. So this is more negative, right? So this might be like, say, -8 and maybe -15. I'm just making up numbers, but I'm happier if my bank account is -8 than -15. I'm sad either way, but I'm happier. Does that make sense? Like, less negative is actually greater. Alright, let's turn it over. Yeah. F prime of k, so that's this line right there. F prime of g, would be this line right there. And so, I mean, it's an estimate, but to me, the k is a steeper slope than the g. It's not like, if you put equal, I'm okay with that. Yeah, I don't have a problem with that. If you put less than, I think I could argue that, but. Any other questions on the front? Alright, let's look at the back, and we're going to start to get into drawing them a little bit. Okay, so we get like these two levels, and a big part of the class, there's going to be a third level down the road, is going back and forth between, so like how many have taken any physics, honors, AP, anything? So you have like position, velocity, and acceleration, right? And I think a large part of that class is kind of going back and forth between them. If I give you certain information about velocity, can you tell me this about acceleration? If I give you acceleration, can you go tell me about velocity, tell me about position? That's a really similar thing. Like that part of physics is very calculus. So we get into here's the first derivative graph, the original graph, the first derivative graph, the second derivative graph. You got to be able to like look at a second derivative graph and tell me information about the first derivative and the original. Look at a first derivative and tell me information about the original and the second. And you get like going back and forth. You have to have like these different levels of thinking. So the original graph, this is what I would call the original. The y values on that graph are y values. And that sounds ridiculous to say, but when we start comparing it, I think they'll make more sense. When I'm looking at the derivative tells you slope. So you can look at the same graph and kind of analyze that actual graph or analyze the derivative of that graph. So when I just, like this part up here, you could have done this in advanced algebra, and I don't think you would have thought twice about it. You probably all get it right. When I start getting derivatives in the mix, it gets more confusing. But where is this positive? Well, it's above the axis from -2 to 0. And from 2 to infinity. That's just saying where are the literal y values positive? Where is that graph above the axis? Where's that negative? Negative infinity to negative 2. 0 to 2. There's that 0. X equals negative 2, x equals 0, and x equals 2. Now that's not really a calculus question. More of an advanced algebra question, but you have to answer it because you think we go back and forth between the two guys. This is what we're really getting into. So I'm going to answer these questions about the derivative, and then I'm going to go through and sketch the derivative and try to show you how they interact. So where is the derivative positive? This is basically just saying where is the slope positive. Derivative and slope are the same deal. So like if I were to draw tangent lines all over this graph at every dot, where would those tangent lines be pointing up? So my slope is positive. Like right here, is the slope positive? Yes. Here? 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 We start to, that's not positive anymore, right? So all the way up from negative infinity to negative 1, we have a positive slope. Where else do we have a positive slope? It's supposed to be at 1. I just can't draw. 1 to infinity, right? 1-ish to infinity. Where's there a negative slope? Negative 1 to 1, because that's where this graph is going down. And then where's the slope equal to 0? These two spots where we would have like a horizontal tangent line. So x equals negative 1 and x equals 1. So I'm going to try to draw this. I'm going to go through how I would think about drawing it. I've got a couple of ways I'm going to show you how to draw it because people's brains work differently. I'm going to try to go through different examples. So the first thing I would do, if we're told to draw the derivative, is I would go through and find the spots that you know exactly what the slope is. The only times that happens is if the slope is 0. You don't, like any other time you're estimating, okay, yeah, here the slope is positive, but I don't know what it is. Here the slope is negative, I don't know the number. But right there, I know the slope is exactly 0. So I'm going to draw my derivative graph on this same graph, and I'm going to draw my derivative graph just in blue pen. And this is a coordinate on the derivative graph. So this says at negative 1, the slope of the original graph is 0. Where else does that happen? At 1. So that's the start. And then that basically splits your graph into parts. And you're going to look at each section independently. So we got 2 dots that kind of splits my graph into 1 section, 2 sections, 3 sections. We're going to look at each part separately. In this section over here, is the slope positive or negative? Slope is positive, right? So like that x-axis doesn't matter anymore. It's almost like it's not even there when I'm looking at it. So I'm just looking like around it, like is that sloping up or sloping down? So this is a positive slope. But as we get closer to x equals negative 1, is the slope getting true or false? The slope is getting closer to 0. True, right? Do you see why it's true?
Yeah.
So the y values of my derivative need to start off positive and get closer and closer to 0, and this should be 0 right when I hit negative 1. So like right here, the slope, so if I call this point A and this point B, which one of those has a bigger slope? A does. So like if I look up, A should have a higher y value when I'm graphing the slope, right? Because this graph is going to represent the slope. So because this is steeper, we have a higher y value. All right, go to my next section. Slope positive or negative? Negative. So my derivative graph needs to have negative y values. So should I be above or below the axis? It should be below the axis. So, but I need to get back to 0 by here, right? Because what's the slope like right prior to -1? Isn't the slope getting back to 0? If you notice, your tangent lines would have like a slightly negative slope, more negative slope, and then a little less, and then back to 0. So we want the y values of our derivative graph to be slightly negative, more negative, so right here is where they'd be the most negative, and then start coming back to 0. This is a little more advanced than we might be ready for, but it might actually help people. This right here is called an inflection point. Can you see how the graph changes from being basically an N to a U at that spot? That should be the bottom of your little hill down here. Those should match up. I'm not really going to hold you responsible for that yet, but just so you know, start thinking about it. Now in this last section, are my slopes positive or negative? Positive. And are they getting closer to 0 or further away from 0? Further away because it's getting steeper, right? So what should my y values be? Positive and getting further away from 0. So going up like that. Now there's also this thing, I don't even know why this makes sense, but every time I say this, people answer it correctly. How many wiggles would you say are in this original graph? 2. I don't ever talk about wigglers, but everyone just says 2. So I'm looking at like that's one wiggle and that's another wiggle. Is that a fair enough word to use for that?
Wiggle is not exactly a common unit, so it's missing.
I get that. Does that make sense how I'm using it now? Okay. So in general, your derivative graph will have one less wiggle. Now if it's sine or cosine, like how many wiggles does sine have? Infinite. So like one less doesn't really help you because it's still basically infinite. But if it's a regular graph, like with an x squared, x to the third, x to the fourth, x to the fifth, like one of those, your derivative graph will have one less wiggle than your original. So that's how because my original here has 2, my derivative has 1. If I took the derivative of a parabola, which has 1 wiggle, what is 0 wiggles? What's like the next level down? It'd be a line. 0 wiggles would be a diagonal line. What's less wiggly than a diagonal line? The horizontal line. Then we're kind of stuck. The wiggle is like, it's not an official term or anything, but it just helps you kind of like, cause some people will get to here and they'll be like, do I do curves? Do I do straight line? Alright. What can I explain again? Go over what's not making sense? How are we doing? Let's try the next one. Now, there's plenty more. Like I can make up more. I mean, it's not like this is our last chance to practice. So you guys try. I wouldn't try to graph it necessarily yet. Although you can if you want. Try the positive, negative, 0 stuff. This is supposed to line up like right above that. Right above that. Again, I'm not like the perfect drawer, but that's what I was going for. x positive. I think I can see a lot of people say it's positive between -3 and 4. It's actually not true. It's not positive at 0. So you got to separate that and say -3 to 0 and 0 to 4. Negative, over here and over here, and 0 at those 3 spots. Is the f of x part okay? Does it make sense why? Are we still working on f prime? Or should I go ahead? Alright. So f prime should be positive all the way up to -2. Infinity to -2. From 0 to 2. And that's it. That's the 2 spots that we're like sloping up. Negative, we're going to go from -2 to 0. And 2 to infinity. That's 2 times we're going down. Slope would be 0 at 3 spots. X equals -2, x equals 0, and x equals 2. Is that okay for the f primes? Okay. So to graph it, did you guys try to graph it or not yet? Let's try it. Why don't you try to graph it? And maybe you do it in pencil, or maybe you like do it in your head. You don't want to, if you're afraid to write the wrong thing on there, but give it a shot first, and then I'll go through it after. But they're graphs, so I can only put like one on a page. So it looks like it's way more problems than it actually is. No, I just forgot it was. So how many wiggles are in that graph? 3, you agree? So your derivative should have 2. See, that gives you an idea of kind of the shape. It's going to be either that or the opposite, either like a up, or a down, up, down type of thing. So I would start by putting the spots where I know what the slope is. I know the slope is 0 there, I know the slope is 0 there, I know the slope is 0 there. And those 3 dots kind of section my graph into 4 parts. Up prior to that first part, is my slope positive or negative? Positive, so my drawing should be above or below the axis. Above. And the slopes get closer to 0 as I go left to right. So I need to start off higher, same way I did in the last one, and get closer to 0. In that middle section, slope positive or negative? Negative. And by the time I get to the end of it, what should my slope be? 0. So I'm going to go below the axis, but I know I have to bounce back up. And if you're being really, ahead of the game a little bit, this right here is your inflection point where it switches from like curving down to curving up, and that should match up with the bottom of your hill. Again, you're not responsible for that yet. I'm just talking about it. Just might help some people. All right, third section, positive or negative? Positive, but by the time I get to the end, I need to be at 0. So I'm coming up and then down, and again, there's another inflection point. That should match the top of your hill if you're being that picky about it. And then negative. So we have 2 wiggles. 1, 2. And the size of your hills doesn't matter. So some people might have gone like way down and then way up and done that. That's totally fine. I'm looking at the shapes. So do I see a U here that goes through those 2 spots, and do I see like an N shape there that goes through those 2 dots? If your N is taller than someone else's, that is not an issue at all. How many had a graph that looked something like that? Alright. Questions? What could I go over? Anything? Alright, let's let's start looking at this packet is just more practice drawing. The letters are supposed to help you. If they don't help you, ignore them. But let me show you what they're designed to do. So these are, everything on here I gave you is an original, and I'm trying to get you to graph the derivative. But what I wanted you to think about was that every letter I gave you is the slope positive or negative. So like at A is your slope positive or negative? Negative. So the y value, you better be below the axis when you start graphing the derivative. I don't know how far below. We're just basically know it's below, but at least you can put a dot below the axis because the slope is negative. At B, what's your slope? 0. At C, slope should be positive. At D, slope should be 0. At E, slope should be negative. At F, should be 0. And at G, it should be positive. And then if you connect those kind of with the wiggles in mind, this is more like a sine cosine, so the wiggles don't necessarily apply. Something like that. Does that give you an idea what the letters are supposed to be doing? It's supposed to be helping. I'm not quite sure they do, but. Number 2, then I'll let you go after this one. I'm just going to do a couple with you to get started. At A, it's slope positive or negative. Number 2, negative. So my derivative graph needs to be below the axis. At B, slope should be 0. At C, slope should be positive. At D, slope should be 0. At E, slope should be negative. And then this graph has 2 wiggles, so my derivative should have 1. One wiggle is a parabola. There's just the question of is it right side up or upside down. This one will be upside down based on the dots. I'll be honest, I still use that ABCD. Sometimes graphs get goofy and there's asymptotes everywhere and just like a piecewise or it's just confusing. So I'll break it down into little segments like this. Here's above the axis, here's below, here's 0, and connect it that way. So it's just kind of a tool to fall back on if you would like, yeah. You could have drawn one like this too. I mean, all right. This? No, that's going up forever, so this should probably go up forever too. Should we do 3? Because that's a little different. Let's do 3. Why not? A is your slope positive or negative? Negative. B, 0. Now think about it before you make your next dot. This has 1 wiggle. What has less than 1 wiggle would be 0 wiggles, which is what? A line. So then when I make my C, I got to kind of remember, okay, this is going to be a line. Yeah, it's going to be positive. Try to make a line. You don't know the slope of the line. Like if yours is like this, that's totally fine. If yours is super steep, that's totally fine. We don't really have that information at our disposal quite yet, but we should be able to get you a line. So there's a few more of those. And then there's some, like, the software stuff. There's some multiple choice on there. And then there's some of the software stuff where there's not multiple choice. This whole package is graphing. It's not as bad as it looks. Because like I said, it's like 1 page per question. Because they're giant graphs. This is what I want you to work on, have done for tomorrow. Yep. Okay. Yep. So what's the slope at A? 0. What's the slope at B? 0. What's the slope at C? 0. They're all positive and they're all the same, right? I don't know what the number is, but I know that the slope at A is the same as the slope at B is the same as the slope at D. So wherever you make it, it's got to be the same height, and it'll be a horizontal line.
to say that it will always curve opposite.
Like this curve
Like when you direct it, it'll always go like that, something like that. Like not exactly, but like if that's going down.
If this is going down forever, is your derivative
Yeah, it'll always create this kind of fishtail look. Pattern recognition is something I've kind of designed, so
I don't really understand the fishtail. I'm not sure what you're.
So okay. So
What you're
1 second. Let me erase yours. So A is positive, B is 0. You do that, and it ends up like that.
Okay.
Right?
Yeah. Well, it's a lie actually, because this says one language, so
Okay. So either way, but
it
looking
doesn't change your thing.
no, because that's still 0, and then that comes to there.
Okay.
About. But if we separate it from just this section, it'll always end up.
Opposite on the other side of the axis.
Yeah. So it like a. Yes, that's what I mean.
Yeah. So yes, because these, if you're here coming up, your slope's going to be positive. So your y values on your slope down is start positive and go down, and vice versa. But this wouldn't be curved, is the only thing. So it doesn't quite match symmetrically because.
That's fair. And maybe this was a bad example. I was seeing this more where it'd be flipped across the line. I guess is how I would word that. But
I would be careful about thinking about that.
why?
Well, the line thing is one.
Other the line is
And it's not flipped about a point like the whole way across, right?
true, but that's what I'm saying. Like, but for just this section, for the section from their infinity to that section, it will be flipped across a x equals line.
No, so here's what.
Excluding asymptotes, I guess, too.
Well, so I mean, if we start excluding.
Okay, then it's.
That's what I
that's
mean.
fair.
Like, I'm afraid you're
That's fair.
going to over-apply it.
Okay, that's fair.
Like, yes, it's a clue for, I think, probably most.